Hi guys, so welcome back here at the Easy Engineering Tutorials. This time is we're going to solve one problem in uh, pre-stressed concrete beams. So ito yung problem natin. And then gusto natin makuha yung mga stresses tsaka yung mga allowable bending moment and maximum uniform live load, no, na kaya nung pre-stressed beam natin. Okay, so bali yung problem is meron tayong 300 by 550 mm na pre-stressed beam has a span of 12 meters. So bali meron tayong 300 by 500, no, yung depth nito is 550 mm. So yung beam natin is meron siyang span na 12 meters. Okay, so uniformly distributed yung loading natin, no? Kasi meron tayong dead load tsaka live load. So yung pre-stressing steel natin or yung tendons, meron siyang cross-sectional area na 774 square meter na naka-install 70 mm above the bottom of the beam. So bali dito meron tayong area nung pre-stressing steel natin, which is 774 square mm. Okay, and then that is placed so 70 mm above the bottom nung beam natin. Okay, so ngayon yung initial tendon pre-stress, so may initial pre-stress to, no? So bali yung FI natin dito for this tendon, so meron siyang FI initial pre-stress na 100 1,100 megapascal. So ito yung initial tendon pre-stress. So yung specified strength ng concrete natin is given. We have 34.5, and then for the tensile strength of pre-stressing tendons natin is 1725. So ano daw yung top and bottom stresses ng beam natin sa midspan. So ito yung midspan natin at center line, for instance, at distance 6 meter. So at midspan, sabihin natin at midspan. After the tendons are cut, and then ano daw yung stresses at the top and bottom of the beam at the midspan, assuming may losses doon sa pre-stress natin, no? Pre-stressing force, which is 18%. So meaning yung remaining forces na lang ng tendons is 82%. Okay, so ano daw yung mga maximum allowable bending moment at the midspan in compression and in tension, no? So given yung mga allowable stress and compression natin, which is 0.45 FC prime, and the allowable stress in tension, which is 0.5 square root of Fc prime. And ano daw yung maximum uniform live load that the beam can support in addition to its own weight. So to solve this problem, so gawa natin to ng stress diagram, no? Stress diagram. So bali dito, ito yung cross section natin. Ayan. So dito yung bakal na, ito yung neutral axis. Then nandito yung bakal natin, yung tendon natin. So bali yung tendon natin is meron siyang force P. So ito naka-place yan 70 mm above the bottom. So alam natin yung dimension natin for ito, yung total depth natin. So we know yung depth na yan is 550, no? So this one is 550. So bali yung location ng neutral axis is at distance 550 divide 2, diba? So 550 divided by 2, that is 275. So meaning yung distance din dito is 275, no? So yung force P, itong force P, so that is at distance, no? Located at distance E. E is our eccentricity. Okay, so that is 275 minus 70, no? So we have 205 mm. So this is 205 mm. So okay na tayo dyan, no? So yung ginagawa natin ngayon dito is kino-convert natin yan, diba? Meron kang eccentrically loaded, no? So this is eccentrically loaded, no? Kasi may E siya eh. So yung gagawin natin dito is ligay natin lahat yan sa neutral axis with moment, no? So bali meron itong equivalent point load plus moment. So bali magiging tsura niyan okay, so parang ganito. So instead na eccentrically loaded siya, so andito na siya sa gitna, no? Sa neutral axis mismo. At saka may moment siya, no? So may moment siya, no? Ganyan, no? Okay, so pag ganyan yung moment niya, so bali diba, yung ikot nito is pag ganyan. So ngayon meron kang load P dito, tsaka may moment ka na P times yung eccentricity E. So yung P natin, the pre-stressing force, so sa tendons man to, no? So that is equivalent nung stress dito sa tendon, which is given. tsaka yung area ng pre-stressing tendons natin. So, bali yung P natin is equal to, we have 1,100 megapascal multiplied by area ng pre-stressing tendons or yung steel natin, which is 774. So, divide na lang natin to ng 1,000 para yung sagot naka-kilonewton ulit. Okay? Okay, so meron tayo dito ngayong pre-stressing force na 774 divide 1,000. So, we have 851.4 kilonewton. And then, yung moment, we have P times E. So, this is 851.4 kilonewton times 0.205 meters. So, 851.4 times 0.205. So, yung value dito is 174.537 kilonewton meter. So, ito na yung moment tsaka yung force natin. So, take note, costo ng tendons, no? Yung pre-stressing tendons natin. Okay? So, first is due to P. So, sa due to P, meron tong compression, no? Okay? So, meron siyang compression. So, meron tong compression, parang ganito. So, hindi dapat dito yan. So, ito yung sa mids pa natin, no? And then, gawin ko na lang ganito. So, yan yung moment. Okay, so, ngayon, due to P, so, bali sa left side, no? Parang ito yung kinonsider ko. Hindi ito na-portion, okay? So, parang ito yan, no? Para hindi ako siya nakakalito. So, ngayon, we have due to P, so this is compression. So, meron tayo ditong negative force over area. So, negative meaning sa left side. So, unan din dito, this is negative force over area. So, this is compression. So, bali yung force na yan. So, yung force over area. So, yung pre-stressing force natin is 851.4. So, times 10 to the power of 3 para Newton. All over yung area natin, which is yung overall cross-sectional area, 300 by 550. So, this is 300 by 550 square mm. So, therefore, we have 851.4 times 10 to the power of 3, 300 times 550. So, yung sagot dito is 5.16 megapascal. So, ibig sabihin, ito pala is negative 5.16. Ganun din dito, this is negative 5.16. Next is due to moment na P times E. So, ang titignan mo, iten niyang isimangot yung beam natin, no? Kasi dahil yan sa negative moment, no? So, bali, iten nitong iganito yung beam natin, no? So, parang ganyan, no? So, bale, yung dito na part, parang yung fiber dyan is intention, no? Parang hinihila. So, this is taken as positive. Dito sa baba naman is parang pushing, no? Yung mga fiber dito. So, this is in compression. So, bali dito sa value natin dito, so dito sa top is positive, so this is positive MC over I, and then dito sa baba is negative, no? So negative MC over I. So dito sa neutral axis, so this one is 0. So bali meron tayong ganito, no? So meron tayo ditong tension, and then dito meron tayong compression. Okay, so yung value na yan, ito yung value na yan, that is equivalent to MC over I, where yung M dito is yun yung PE, so C over I. So yung PE natin is 174.537 times 10 to the power of 6 para Newton tsaka mm, multiplied by C, which is ito yun. So yung C natin is 275. So 275 all over yung I natin, which is yung cross section is 300 by 550. So this is 300 by 550 cube divided by 12. So bali meron na tayo dito 174.537 times 10 to the power of 6 times 275 all over 300 times 550 cube divided by 12. So yung sagot dito is 11.54. So ito pala is negative 11.54, while dito is positive 11.54. So okay na tayo dyan, ha? Next is itong sa caused by dead load, no? Okay, so di pa natin alam yung sa live load na part, no? So sabihin na lang natin yung sa dead load na lang muna. So sa dead load is meron tayong dead load sa beam. So concrete area nung section, okay? Ito yung beam weight. So bali yung beam weight natin is meron tayong 23 point density ng concrete. So alam natin that is 23.5. This is in kilonewton per cubic meter multiplied by 0.3 meter by 0.55 meters. So meron na tayo 0.55. So bali yung sagot dito is 3.8775 kilonewton per meter. So ito na yung dead load natin. So due to uniformly distributed load, so we know that the maximum load for uniformly distributed load for a simple span is WL squared divided by 8. So this one is 3.8775 times yung length natin, which is 12 squared, all over yung 8. So this is 3.8775 times 12 squared divided by 8. So yung sagot dito is 69.795. This is kilonewton meter. Kaya tayo dyan, ha? So, bali dito is due to moment dito sa dead load. So, meron tayo ngayong, so bali yung beam natin is iten yung may ganito, no? So, meaning yung dito is in tension, yung mga fiber na to. Well, dito is in compression, no? Yung fiber na yan. So, bali dito meron tayong negative MC over I. At neutral axis, 0. And then dito is we have positive MC over I. So, bali, yung stress diagram nito is ganito. So, ganyan, no? So, bali ito is subject to compression. And this one is subject to tension. So, kukunin na lang natin yung value dyan, ha? So, we have MC over I. So, yung moment dito is cos ng dead load. And we have C over I. So, yung M natin dito is 69.795. So, we have 69.795 times 10 to the power of 6. So, bali it is Newton mm, no? Yung C is 275 pa rin. Diba? So, ito pa rin yun, no? Ito pa rin yung C natin, which is 275. So, we have 275 all over yung 300 by 550 cube all over 12. So, meron na tayo dito computer ko muna. So, this one is 69.795 10 to the power of 6, 275. So, ito na, no? So, we have 4.61 megapascal. So, bali dito, this one is positive 4.61. And then dito is we have negative 4.61. So, okay na tayo, no? So, bali, pwede na natin i-combine to. So, for combined stress, ito. So, masolve natin dito yung sa top tsaka yung sa bottom, no? So, bali dito sa top combine stress. So, for top, so add lang natin to. Ito plus ito equal dito. So, we have sa top, meron tayong negative 5.16 plus 11.54 plus negative 4.61, no? So, bali dito is negative 5.16 plus 11.54 minus 4.61. So, therefore, 5.16 plus 11.54 minus 4.61. So we have positive 1.77 megapascal. Positive sign indicate na ito pala is in tension. So this is positive 1.77. Neutral axis 0. Then dito naman sa bottom, so ito yan, no? So we have negative 5.16 plus negative 11.54 plus 4.61. So this one is negative 5.16 minus 11.54 and plus 4.61. So bali dito meron tayong negative 12.09 megapascal. So negative sign indicate na ito pala is in compression. So meron tayo ngayong negative 12.09 megapascal. So bali ito yan. So this one is in tension, while this one is in compression. So ito na yung sagot natin. So bali dito sa problem, yung stress at the top is, sagot dito is positive 1.77 megapascal, while dito sa bottom is negative 12.09 megapascal. So ngayon is paano naman if may losses sa tendons natin, no? Sa pre-stress natin na 18%. So if may losses, so ganito yung mangyayari, no? So meron tayong losses in pre-stress na 18%, no? So meaning yung remaining strength na lang, so yung remaining pre-stress na lang is 100 minus 18, no? So that is equivalent to 82%. So ito yung sa tendons na part, no? So meaning itong due to P tsaka itong due to M na P equals E, ito sila is sa tendons na, no? Ito siya is pre-stressing tendons, no? Yung ito sa pre-stressing tendons, ito is due to load, no? Due to uniform load, no? Ito na part. So bali dito sa top natin ngayon, magdagdag lang tayo ng 0.82, no, as multiplier niya, meaning 82% ng 5.16, no? So parang ganun yung mangyayari. Okay, and then we have plus itong 11.54, di ba, sa pre-stressing din yan, tendons. So multiply pa rin tayo dito ng 0.82, meaning 82% na lang nung 11.54. Pero dito sa uniform load hindi kasali, no? So bali at is lang yung 4.61. At is lang yan. So yung mangyayari dito is negative 5.16 times 0.82 plus 11.54 times 0.82 minus 4.61. So we have 0. So we have 0.62. So again, this one is in tension, so this is in megapascal. And then dito naman sa bottom is we have negative 5.16 times 0.82 minus 11.54 times 0.82 plus 4.61. So, bali yung sagot dito is so we have negative 9.084 megapascal. So yung negative sign indicate na this one is in compression. So bali yung sagot natin dito is for top and bottom. So for top we have positive 0.62 megapascal, and for the bottom we have 9.084 megapascal. So ito na yung mga answer natin. So next is ano daw yung allowable bending moment at the midspan, assuming allowable stress in compression is 0.45 FC prime. And then may losses pa rin to, no? May losses pa rin to na 18%. Okay? So may losses pa rin yan ng 18%. So yung mangyayari dito is so again, may losses pa rin yan. So bali dito is assuming pa rin to. Assuming the losses in tendons is 18%. So pag ganun yung mangyayari, so ganito siya, no? So ito pa rin yan. Kunin ko lang to. Copy. So yung maximum allowable bending moment. So we have maximum allowable bending moment. So, bali yung sagot dito is so ito mapapalitan to, no? Ng MC. Kasi yung tinatanong is ano daw to, no? Parang dito na part Q to M. So, minus M, so 10 to the power of 6 para Newton mm, then multiplied by C, which is 275, all over yung 300 by 550 cube divided by 12 na. And it must be less than or equal sa allowable. So yung allowable natin for compression is given, so that is 0.45 ng FC prime. So this one is 0.45 ng FC prime, which is given 34.5. So bali dito this is 34.5. So ngayon we will have now the moment. Okay. So negative 5.16 times 0.82 plus 11.54 times 0.82, and then minus alpha x times 10 to the power of 6 times 275 all over 300 times 550 cube divided by 12, 0.45 times 34.5. So we have I forgot the sign. So dito sa allowable bending stress natin, we know, I forgot the sign, it must be negative kasi compression to eh. Diba? So kailangan compression to, so dapat may negative yan. Okay, so this must be negative 0.45 FC prime. So meron na tayong 313.94 kilonewton meter. So ito na yung sagot dito for C. Yung sagot dito is 313.94 kilonewton meter. And for the tension na part, kasi ganito yan so sa section natin at midspan, so bali ito yung neutral axis so sa midspan ka, ito yung neutral axis, so bali ito is subject to tension, ito is end compression. So bali yung stress diagram dito is parang ganito yan. So ito yung compression, negative, including sign negative 0.45 FC prime. Then dito is positive 0.5 square root of FC prime. So ito yan 0.5 square root of FC prime. For the tension, ito compression. So including sign yan. So dito, ito pa rin yun. Kupihin ko lang. So yan pa rin yun. And then we just need to equate this one. It must be less than or equal sa positive kasi tension. 0.5 square root of 34.5. So thus, yung moment capacity natin is negative 5.16 and minus 11.54, 0.82. So this one is must be plus to, and then to negative 11.54, and then we have 0.5 square root of 34.5. So meron na tayong 251.54 kilonewton meter. So yan na yung sagot dito sa tanong na maximum allowable bending moment. So this is positive 251.54 kilonewton meter. So next na tanong is ano daw yung maximum uniform load that the beam could carry. So bali dito is maximum uniform load, no? So again, in order to be safe, dapat yung actual moment must be less than or equal sa capacity, no? Or yung allowable. So yung sa actual, we have W, we have the dead load and the live load, then length squared divided by 8. Then yung allowable is yung lowest ng dalawa. So dito yung mag-govern in terms of capacity is ito siya, no? Allowable kasi ito. So meaning capacity yan. So this must be 251.54. So we know the dead load is, na-compute na natin to. So dead load is 3.8775. So bali 3.8775 plus the live load. And then yung length natin is 12. So we have 12 squared divided by 8. So this must be less than or equal sa 251.54. So thus yung live load natin is 3.8775 plus alpha x times 12 squared divided by 8. So this must be less than or equal to 251.54. So this one is 10.096 kilonewton meter. So yan na yung sagot dito. So bali dito, this one is 10.097 kilonewton meter. Okay, so I think that's it, no? I think that's it for Prestressed. See you in the next video.